All right, class, welcome to another episode of Brand Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, we'll be talking about chapter 13.8, Reciprocal Function Notes. You guys can see right here, these are your reciprocal functions, right? Secant, cosecant, cotangent. And just a reminder, I like to think of secant with cosine, right? The S and the C, okay, they're always different. Same thing here, C and the S, cosecant and sine. And then cotangent, I mean, you have the word tangent in there, so hopefully we can't get that one wrong. So again, these are just the reciprocals. So you take the reciprocal of cosine, sine, and tangent to make it 1 over that function. Over here, just a little brief reminder again, how in quadrant 1, okay, secant, cosecant, cotangent are all positive. Quadrant 2, notice which one is positive. It's just a cosecant because that deals with sine. And then here, quadrant 3, cotangent is positive because that deals with tangent. And then here, secant is positive because that deals with cosine. And remember the acronym for this is all strippers take cash, okay? So this is more for pre-calc and calculus, but just to kind of give you that little acronym to know where it is positive for each of those functions. All right, let's get going with these 3 graphs. So this is what they look like, okay? Give me the answers right there. That's what the inverse, sorry, not inverse, the reciprocal function look like. Okay, the reciprocal function. It looks complicated, but it's actually quite easy to see once you understand the reciprocal here. So for this one, we're dealing with secant. Right now on this graph, I want you to draw your cosine graph. Okay, so draw me the parent function for cosine. And I'll start you guys off here. So, right, it starts at the amplitude, midline, min, midline, max. Okay, so it makes that V, right? But you want to make sure you curve it here. But please do it with dashed lines, okay? Because remember, your actual answer is your secant graph. So do dashed lines here. It's going to look like this. Okay, so as you notice, and if you want, you can keep continuing on. It's no big deal. If you notice these 5 points, look at this, look, these 5, the original, okay, is connecting to the reciprocal here. So one thing I want you to take note of, look at all of your min and max for cosine. Okay, look at those 3. So it turns out, okay, your amplitude, okay, switches from min to max or max to min. Okay, they switch. Let me explain that here. So you look here. This here right now is a max, right? This is a max for the cosine graph. But what's the reciprocal? Like what's kind of like the, when you flip it, when you flip this max, it becomes a minimum, right? This is now a minimum for your secant graph. Same thing here. For your cosine, this was a minimum, right? For your cosine graph, it was a minimum, but you flip it, so now it is a maximum. Okay, pretty neat there. Next one. Okay, notice your zeros now. Okay, your zeros are now your asymptotes. Zeros are asymptotes. Boom. So I'm gonna look at my zeros here. Okay, zeros. Okay, the 0 is where it intersects the x-axis. So here, probably do a different color. This is actually part of your real graph. You see these asymptotes here, right? That's how we kind of create that secant function. So for this, your zeros are your asymptotes, okay, for your secant graph, okay? We're gonna do the same thing for your sine, okay? So this is your cosecant, this is your reciprocal for your sine graph. So again, feel free to pause the video here if you want. I'm going too fast, but pause it, test yourself again, remind yourself what the sine graph looks like. And I'll be doing it here myself. So it starts at the origin, max, midline, minimum, midline. Again, do a dashed lines. Boom. You can complete it too if you want. Okay, so it's the same drill. Okay, look at this here. These 5 points. So again, let's emphasize this. Your amplitude becomes your min or max. So here, this is your amplitude, or this was your max, right? It was your max here, but now it became a min. Over here was a min, and now it became a max. Okay, that's where that reciprocal, it gets flipped. And so if you think about it too, the zeros, like what's the opposite of intersecting a line? The opposite of intersecting a line is actually an asymptote, right? Because the definition of asymptote is where the graph does not intersect. Okay, so that's where these are your two big ones. Okay, the reciprocal of a 0 becomes an asymptote. The reciprocal of, let's say, a max here becomes a min. Okay, so there's just 2 main steps here to graph. So let me write this. Steps to graph. Okay, we're going to simplify all this in 2 easy steps. First step is to graph your sine and cosine with dashed lines. Okay, just graph it with dashed lines because it's not your official answer. Once you do that, then you draw parabolas, right? The U shape is called parabola. Draw your parabolas and your asymptote. And in the end, that will get you your official secant or cosecant graph, okay? So this here is pretty important, okay? Just kind of simplify the 2 steps. Again, looks complicated, but once you start doing some, you get the hang of it. Cotangent is kind of weird, it's on its own. We'll do that in a bit, but let's do some practice graphs here. So again, we're gonna follow these steps. So for cosecant, let's look at cosecant. Cosecant, reciprocal of sine, right? So let's change this to a sine graph, just so we kind of know how to work with the dash graph first. Amplitude is 3, okay, same drill. Period. Oh, let's do your b first. B is 1, right? Your period is 2 pi over b, which is just 2 pi. Notice on your graph, you're not dealing with radians, you're dealing with degrees. 2 pi in degrees is 360. Okay, so I'm gonna mark this here. Again, I'm doing sine, so I know it's gonna be here, here, halfway. Again, my amplitude is 3, so with 90, it's gonna be at 3. At 270 is -3. Again, we're doing dash. Okay, we're doing dash lines first. Okay, boom. That was your first step. Okay, you still just graph your sine and cosine function. Next, let's draw your asymptotes first. Okay, so where are your zeros? 0, 0, zeros. I should be able to see 3 asymptotes here. I'll make that blue. Bang, bang, bang. Okay, pretty good. And then from there, again, this was a maximum. So now you make it into a minimum with that parabola. And then you make this a max with that parabola. Okay, so your official answer is in blue. Okay, anything in blue is your official answer. Your asymptotes are in blue. And those parabolas are in blue, okay? Why don't you give number 2 a shot? Feel free to pause the video so you can kind of test yourself before checking the answer. I'm gonna go ahead and do it right now myself. Okay, so y equals 3. Okay, sine 1/3 theta, same drill, a equals 3. Period, 2 pi over 1/3, which makes it 6 pi. 6 pi, you do have to change that to your degrees. Okay, remember, multiply by 180 over pi, which gets me 1080. So you know it's gonna end there. Middle, where's the middle? 180 is right here. Boom. And then find halfway. Halfway with this is right there. Asymptote 3, -3. Again, my purple dash is not necessarily part of my answer. It just helps us find your actual reciprocal function. Let me do my zeros here. Boom, boom. Bang. And then draw your parabolas. Opens up here. And then opens down here. Okay. So again, these should look the same, right? The difference obviously is kind of like stretching, compressing here because we're using different units. Okay, let's do, we'll just do number 3. We'll skip number 4. So number 3 is secant, which is going to be cosine. So let me write this here. Y equals 2 cosine 1/2 theta. Again, A is 2, B is 1/2. Your period, 2 pi over 1/2 is 4 pi. Okay, so boom. You gotta remember for your cosine, they start and end with the max. Okay, so don't forget that. Makes that V shape. Boom, boom, boom. Okay, so take a look there. Again, if I'm ever going too fast, feel free to pause the video to test yourself. Okay, a little sketch here. Again, I always like to find my asymptotes first. Okay, the asymptotes are just the zeros. Okay, again, they're reciprocals. So wherever it crosses the x-axis, the reciprocal, kind of like the opposite of that, is not crossing it. aka the zeros become your asymptotes. Boom, boom. Okay, and then from here, we're going to draw your parabolas. Okay, so kind of sketch this here. U shape. If you want, I mean, you're only required to do half the parabola. Like, I would know what you mean. If you want to kind of fill it up too, you totally can by doing that. Okay, and that's how you do your secant one, okay, for cosine. Okay, on to the fun one. Let's go to tangent. So go back, flip your papers back. We're doing tangent. So for tangent, there's 2 different things compared to your tangent and cotangent. Okay, so again, this is your tangent function. Y equals tangent x. The main difference, if you recall, let me draw the tangent over here. Here's your regular tangent. Usually you do your pi over 2, right? Negative pi over 2. And that will be your actual asymptote. And then where does it cross the x-axis, right? Before, it would look like this. Okay, so I'm gonna do that here. Boom, boom, boom. Okay, that was your regular tangent function. So if you notice, there's 2 things that are different. The first one, you don't actually start in the middle here, which is kind of nice now. Now you actually start just like how sine and cosine starts. You start with a 0, right? 0 to pi. Versus here, you kind of did it negative pi over 2 and pi over 2. So you kind of had the graph on both the negative and positive side of the x-axis. So that's one difference. Okay, so it's shifted. Okay, if you think about it, this 0 here, right? Remember, what's the opposite of a 0? It's going to be an asymptote. Boom. Now look here. What's the opposite of an asymptote? It would be a 0. Okay, so look here. There's a 0 here, 0 here, 0 there, 0 here. Okay, so the asymptotes become a 0. Let's make a note of that. Okay, so your zeros are asymptotes, asymptotes. And then vice versa, your asymptotes are 0. So I really want to emphasize there should be asymptotes right here, at pi, at 0, at pi, negative pi. Okay, so those are now my asymptotes. And just some quick steps. I write the steps on the side here. I know it's a bit small. But again, steps to graph. Try to make it simple here. Steps to graph for your cotangent. Steps to graph is going to be step 1. You actually don't need to draw the tangent, right? You can just start at the origin. Okay, start at the origin. Your asymptote is the beginning, and end of your period. So always label your asymptote first. It will be the beginning and end of your period. Second, the other thing that's different, sorry, I'm kind of writing small on the side here. The other thing that's different is, notice for your original tangent, it increases from left to right. So if it increases left to right, over here was decrease left to right. Okay, so your last step is to draw a decreasing tangent graph. Okay, so there's your 2 steps there. All right, let's do these 2 examples. Feel free to flip back and forth to see your steps here. Okay, I know it's a little different, but we're just gonna get used to it. All right, number 5. So again, number 5, A and B are still the same. So let's look here. Your A is 2. If you want, you can do your 2 tangent, 2 theta. You necessarily don't really have to. Your B is 2. Your period is pi over 2. And again, always check your axis. We're dealing with degrees, so we're going to use 90 degrees. So 90 is right here, okay? So again, remember your key notes, okay? Your asymptotes is the beginning, your beginning and end. Okay, so your beginning, if there's no real shifting, which we're not doing right now, your beginning is at 0. And then your ending is at 90. This should be 90. Again, that's your full period. Then from there, just find the middle point. The middle point between 90 is like 45, like right here. And remember your amplitude. Okay, so find the other halfway, or this halfway first. That's gonna be like 2, kind of like right here. It's gonna be like right here. Okay, again, it's halfway between this and halfway between 0 to 45. Okay, and that's it. That's gonna be your answer. So cotangent is not too bad, but I guess you do have to memorize a whole nother process in a sense in regards to knowing that your asymptotes are beginning and end, and it's decreasing. Again, whereas cosine and sine, you literally just graph the same graph, but then you just, take the reciprocal. All right, last one. We got A equals 4. B equals 1/2. Again, your period is going to be pi over 1/2, which means 2 pi, which also means 360 because you're dealing with degrees here. Again, start off asymptote at 0, and then asymptote at the end of the period, which is 360. Find your middle point, which is 180, which is half of 360. And then between there, 270, it's going to be 4, and then 4. Again, that's because that's your amplitude. Okay, something like that, a little sketch. Okay, that's it for today's notes. Good luck on your homework assignments, and have a great rest of your day.